So, Dr. Husam, what's going on here?
So this is the autonomous and assistive robotic laboratory, and in this laboratory we deal usually or mostly with the autonomous drive. So we try to build the robots so they can communicate with the human, navigate between the human, and generally saying in a dynamic object. So we try to build an algorithm or a advanced control algorithm will be behaving. So for example, in this example, we try to build the parents relationship, like assuming this is the mother and that is the kid, try to follow their mother. And but this is in natural behavior. We find it with birds, we find it with fish, we find it with many natural inspired. So we inspired with this, so we try to build it or convert it into the robotics. Similar to the ants, how they follow each other, and similar to bees, and so they should work in a meaningful purpose. This is the initial state that we are working on. We have also this robot that we try to make it your mate that can jog with you. This is very fast. This can come over, let's say, in even straight way, and it can recognize the owner, follow the owner, and do some, let's say, emotional connection between the human and the robots. We also deal with other robots like this one. So we have this Robotino. This Robotino, we also do the same thing, but in the industrial application. We have our own developments, like what you see here and what you see there, and we also have a flying drone, but this is still under patent, so I cannot speak a lot. We have other developments like this one. We have it with me, and this robot also meant for the same reason. The LiDAR now is working, and the LiDAR try to map the area. I can show you how the robot would fly, what the robot sees, and similar to here, that's what actually the robot is seeing at this moment, and try to map the area. Although we took this experiment in the other room, in another building, and that's why this is not exactly the same, but that's what the robot going to see through. We try to build a mask around the objects, so the robot will recognize which is a dynamic object, which is not a dynamic object. We do this through ROS. We have some other side of this laboratory, which is assistive robotics, mean those robots that built to help the human beings. And for example, here we use the 3D printer to show the design, to build the finger parts. So like we try to first to copy the mechanism of the human fingers, and but this is the first stage. We try the different mechanisms. So we have around 5 revolutions of this design, like in here or in here or in this one, as I mentioned. We did some experiment in the old versions of these as well, and we have also the human robot or BCI, like a brain computer interface, and so we can show you. So we extract the signal through using the EEG sensor. So we capture the brain activities like here, and these data will be transmitted to the robots and to the other systems, so the users can control based on their brain activity. This is one direction, but we have we working generally with the neurotech group, so we have a connection in the medical side as well, and that's what we try to generally